had used the term that the current is.
Parth, I
Yes,
want
ma'am.
you to please explain me this once again. This A and B.
I am saying that the current is passing through the superconductor, but in this figure, it is not passing through the superconductor. It means inside the superconductor, it is overlapping the material. So, what is the difference? I want to say that.
Parth, first, that is what I would like to understand from shown. Find this
Yes, ma'am.
arrangement. You have explained this arrangement and the next slide again to me, please.
Ma'am, can you repeat it?
Yes, can you explain this slide and the next slide again, please?
Okay. So, first of all, I have said that the superconducting material is placed and through which electric current is passed. As electric current passes through the superconducting material, the magnetic field is induced, as we have studied in standard 12th.
To which one is
So,
the superconducting material, A or B?
A.
Okay, so through A, current will pass.
Yes, but in this figure, it is overlapping.
Overlapping means they are connected to each other.
Yes.
Okay, fine. Move ahead.
So this can also be considered as current inside because it is exactly fixed on the superconducting material A. So the current which is passing just outside the material is considered as current inside. So this figure is true. That's what I want to convey. Next. And yes, this equation is known as Silsby's law. Okay. Now there are three important factors, that is TC, TJ, and HC. Critical temperature, critical current density, and critical magnetic field. These all are interdependent, and I should say that these factors are the defining properties for any superconducting material. So what happens if we change a single factor among this, the other two will also get changed. So I have plotted all the values on three-dimensional axis, and we have got this graph. Here in this graph, the surface comes out is known as critical surface, which means this graph acts as boundary and it separates two distinct states, that is superconducting state and normal state. Any value inside this critical surface will behave as superconducting material, and if we change single factor among these three, then we can get normal state. Anyone have a doubt in this?
Please explain the second point.
Okay, it is one type of example that how it is dependent on each other. It is given that the highest value of Hc and Jc occur at 0 Kelvin, while the highest value of Tc, the highest value for Tc occur when H and J are 0. So from this we can say that H and J are directly proportional to each other, while H, J are inversely proportional with T. Have you got it?
Yes. Yes, you
Okay,
can
so
continue.
till now, any doubts? Okay, so before moving to types of semiconductor, there is one another factor which is called effect of impurity. So what happens when we add some impurity in superconductor? So as we have seen in magnetic field, electric field, that by doing any changes, the superconducting property vanishes. But here in the case of impurity, if we add some impurity into superconductor, the superconducting property does not vanish, but the critical temperature of the superconducting material decreases. This is the small topic of effect of impurity, which I have forgotten to add in this slide. Have you got it?
Yes.
Okay. Now types of semiconductor. We have main two types of semiconductor, type 1 superconductor and type 2 superconductor. Here type 1 superconductor is called soft superconductor. Now, when a superconductor is placed in magnetic field, while increasing it to critical magnetic field, it suddenly becomes normal conductor.
Just a moment. Parth, I would
Yes,
like
ma'am.
to have a second PPT. Mohammed, please go back to second PPT.